Hello everyone, I'm Rahul Shandilya, and in this next lecture of Internet of Things, we will discuss challenges of IoT, the various challenges considered in designing of IoT systems, the challenges considered in managing the security of the IoT, which is very important for the IoT system, and also the challenges. There are some other challenges like ethical challenges, business challenges. So let's first discuss with the design challenge of the IoT. The part points we should consider what fact we should consider while designing the IoT system. The first one is the heterogeneity and interoperability. So we have already discussed that IoT system comprises of various different kind of sensor, different kind of actuators, and different kind of data pattern, and they need to interact with each other. So this issue arises due to the version upgrades and addition of new vendor products. The packet logic has to cater to a multi-vendor or multi-version deployment of the IoT devices. This can be achieved using an API translator. The API translation component can effectively expose a consistent set of APIs and message format in one direction by using adapter subcomponent to manage interoperability between the heterogeneous devices. The component thus has to be reachable from the field area device and must therefore be necessarily expose a public IP. By bombarding this component with bogus requests, it could be possible to induce the backend system into dedicated precious bandwidth towards executing bogus workload, thus resulting in a service outage leading to a DOS attack. DOS attack is here simply denial of service attack, which is very popular inside security. Spoofing is possible in this heterogeneous environment where a malicious node might impersonate another node, possibly a router, to route the data through itself and get unauthorized access to sensitive data. So there are two, we see this, if we design the IoT system poorly, uh, it is vulnerable to the security attack. For example, and this design means heterogeneity and interoperability. If you not consider it properly, that means if two components at the end user are different type of heterogeneous, and if there uh, between them the message is exchanged using some API translator, and if we do not design that API translator properly, then there is a chance that some other uh, component like that can guess the access and thus bombard with the fake data and result in the denial of uh, service attacks. And also it is possible that the intruded component, intruded physical device may appear as something or someone, means they can expose a public IP. So they can make appear itself as familiar devices, and this can gain access to some particular, some important data. Next is connectivity. IoT applications. So, what are the important factors that we must consider while designing the connectivity of the IoT system? IoT applications typically require two forms of connectivity, and either of these have their own set of challenges. The first form is a physical level, where sender and receiver need to communicate using the same PHY and MAC address, that is physical and MAC address. Unfortunately, peripheral IoT devices tend to communicate over low power radio standards like Bluetooth, Zigbee, Z-Wave, NFC, NFC stand for near field communications. The information from these peripheral devices have to be bridged to an IP network over traditional Ethernet. The bridging device act as proxies for the peripheral devices. The bridging device acts as proxy for the peripheral devices, which may be called for MITM, that is man in the middle of attack. The second form of connectivity is the term of service connectivity. So the first form of connectivity was the connectivity of lower level, that is of physical and MAC, and this second form of connectivity is the connectivity of service of connectivity. If packets from a physical device can reach the backend, it needs to be appropriately registered so that the backend can deliver these messages to appropriate service. Any kind of changes to the availability of the service has to be notified to the respective devices. Otherwise, devices will unknowingly flood requests to an unavailable service server, leading to DOS attack. So, why the connectivity issue is important and connectivity factor is important again in designing the IoT system. So IoT systems basically connect our physical devices. These physical devices have some say physical and address or MAC address. So and these devices are of various type and they communicate over various standard like Bluetooth, Zigbee, Z-Wave, NFC. But they have to at some node have to connect with the main IP network, and this is done using some say gateway. So it is possible that due it is possible that similar devices can get access to that gateway if it is poorly designed and can pose MITM attack while designing the physical say network. Right? It is also possible, and another kind of connectivity is the service connectivity. That means uh, the service you provide through whole the IoT system. So if your client means has some uh, unauthorized access, they can flood request, and that leads to the denial of DOS attack again. So both this connectivity at the lower end of physical level, that is first from physical level connectivity, and service level connectivity is important factor while designing the IoT system. Next important point is factor is mobility and scalability. As the mobility of device in the field area increases, there could be frequent disruption in the physical connectivity uh, between the devices with the local bridges. To mitigate rogue devices from latching on to unauthorized services, peripheral devices that move to a new location have to maintain service continuity through secure handoff mechanisms. So, on the other hand, if the service continuity is disrupted owing to the unavailability of bridging infrastructure or other reasons, the isolated node must be extensively re-verified before the resumption of service. In most IoT applications, it is sufficient to verify just the field devices, but in few sensitive situations, it might require two-way verification of the backend system as well. An adversary node might inject some malicious data in a roaming network before moving back to home network and hide itself in the roaming network to prevent repudiation attack. Further, a clone node may illegally want to exploit the mobility to coexist in another node. So, Basically, the mobility and scalability is the important factors. Means, suppose we are designing to track our product, uh, say, means to track our some package goods while it is moving on. So basically, any network cannot is limited. Any single network is limited. So the vehicle, the package has to move from one network to another network. And during these, say, switching from one network to another network, one has properly to do proper handoff. And if this disruption of network is not properly managed, then during this phase, and another rogue devices can enter into our network, and this again can damage the security system of the IoT device, your system. So, so it must. Why? So what should we do? We should basically verify if service is owing to unavailability of the breathing the isolated device must extensively. Means if they we are doing handoff, the isolated device node must extensively re-verified before resumption of the service. That is how we should cope with these challenges. In most IoT, it is sufficient to verify just the field devices, but in few sensitive situations, it might require two-way verification of the backend system as well. So these are the solutions that we must consider while designing the while considering the mobility and scalability of the IoT system. Field deployments of IoT applications tend to grow either horizontally or vertically. In the case of horizontal scalability, uh, so scalability that was for the mobility problem. Now we are moving to the scalability problem. Scalable devices means there are two kind of scalability. One is the horizontal scalability and another is the vertical scalability. Horizontal scalability means simply adding more devices to your system. Vertical scalability that means increasing your devices capacity. In the case of horizontal scalability, hardware load balancing can be used extensively to improve the service availability, increasing the infrastructure. It is thus important to allow only authorized device to pass through. Otherwise, there is a potential for rogue nodes to launch DOS attack by overwhelming the load balancers. So again here, the scalability is done by using load balancers, and again at this junction also it is possible that if you do not look into the security issue, then some rogue device get access to the load balancer and thus launch the DOS attack. Alternatively, in the case of vertical scalability, the network can extend multiple hops. It is thus important to be able to trust intermediate nodes in the field area network. Otherwise, it has the potential to introduce sinkhole or wormhole attack. So another point is that you increase the capacity of your network, that is efficiency of your network, by adding some intermediate nodes. So while adding this node, we must be considered uh, careful that our security is not so weak that another nodes can also, and this addition and removal of the node is done automatically. That is very important. So we must design our system in such a way that any unknown nodes that is which is not the part of your IoT system cannot connect itself to the system. If it is then if it is possible to do that, then we have this sinkhole or wormhole attack. Next point is the addressing and identification. Field devices in the IoT application prefer to use low power radios for the last mile connectivity. As per current practices, coordinated nodes allocate local addresses to the peer device, and these devices do not follow a common standard. Moreover, the addressing scheme of the field network remains hidden behind gateway bridge and makes it difficult to isolate a robot. And since the nodes become untraceable, at a later point of time it might deny for sending a message and thus lead to the repudiation attack. Further, the node can attempt to access unauthorized privileges remain screened from outside network. Even it might take advantage of not being traceable from the outside network and spoof within its network to other nodes, claiming itself to be a genuine bridge of the network. Address this problem, lower power radios must support a common addressing scheme like 6LoWPAN, as we have discussed at the beginning of this, that would enable each node to operate on IPv4, IPv6 addresses. So addressing and identification is very important, as we have seen, because with all these things comes the authentication and authorization, and if we have a loophole in this particular factor, uh, we pose a serious threat to our IoT system security. So basically, any entry point, whether it is at the bridge or gate level or service connectivity, we must be considered to make it safe. For further security, there should be a global repository where device IP mapping can be required authenticated. So, spatio-temporal services. Now we have services of different kinds from the IoT systems. IoT systems have very different kind of services also, technology. So any event in the IoT world and can be characterized by the amplitude of spatio-temporal impulses. Therefore, it is necessary that the nodes in an IoT deployment are reasonably time synchronized and that they are able to tag any data with a spatial geolocation. To achieve this end, this would leverage locations service like GPS or cell tower triangulation or Wi-Fi triangulation. But due to this feature, user location data should not be revealed to unauthorized users, as this might lead to the privacy issues. Also, to ensure that time drift within the fan cannot be exploited for replay attacks, the API exposed by the backend system should ideally be idempotent. Additionally, the backend system must take into account the variance in the location data that is available from the end node. Otherwise, it results in an inaccuracy of fault reporting, leading to incorrect decision. So basically, we also give some spatial temporal services of the IoT system. That means by providing the location of the systems. In these services, we have to take care of the to provide location of the some IoT nodes. So, and this location is basically done by providing, say, cell tower triangulation, GPS triangulation, or Wi-Fi triangulation. So, during that also, it is we must look into the security features properly. Otherwise, any rogue nodes can get access into our system and pose serious threat. Then another challenge is the resource constraint. This we have just discussed in great detail in the beginning of the course also. That the IoT systems are basically comprised of low power devices, physical devices. We are connecting the low power, low computing power, low say, power and low memory devices to the major network. So these resources are very important. The vast majority of peripheral IoT devices are resource constrained. The constraint could be in terms of available computational resources, onboard memory RAM and ROM, network bandwidth, energy availability. As these nodes are open in environment and easily accessible physically, they can be cloned and tampered. Also, as these nodes have very little computation and storage capabilities, they preferably upload the data into the cloud for huge computation and the storage. For this reason, the user data privacy issue was prepaid. So a strong cryptographic encryption and integrity mechanism need to be applied. So that is also a very serious point here. This physical device is not uh, so security from point of security is safe as compared to the general processor, full capacity processor in a computer. So basically, we cannot deploy some say high level or some better cryptographic or security software there. So it is possible, and also physically it is possible to clone this device easily because these devices are very small and have lesser complexity. So basically, you can from the say data exchange, you can simply clone its architecture, your microcontroller architecture, and you can replace that architecture with the real devices, and in this way you can get access, anyone can get access to our system. Data interchange. Here is another point. Each of the different devices in an IoT application can potentially have a different data package mechanism because a specific optimizations on their hardware platform. If an encrypted packet is decrypted and repacked at multiple points in the communication chain, it opens up a security vulnerability include information leakage and user privacy because the keys are being shared between multiple devices. Moreover, as the intermediary nodes are involved in crypto works, they in turn become prone towards resource exhaustion and DOS attacks. For this reason, end-to-end encryption are better preferred. Next is the resource and service discovery. In an IoT application, it is expected that a large number of the end devices are going to be deployed in the field. Therefore, it is imperative that IoT devices can function autonomously. There is autonomy, that is without manual intervention, and that they can discover the necessary service that they need to consume. Therefore, the coordination in the IoT deployment must implement resource and service directories that can be queried on public interfaces. The mechanism like two-way authentication of the coordinator must be done to ensure that a rogue coordinator does not implement fake service and subsequently redirect traffic through itself and may lead to spoofing. Also, due to this discovery mechanism, unnecessary requests to pretend to discover a resource cause a DOS-like attack. As the IoT architecture is hugely distributed, the user data becomes distributed in cloud. So, without proper security measures, it may lead to information leakage and user privacy issues. Accounting information inconsistencies may also rise here unless correct measures have been taken. So these are the point of basically factors that we should consider while designing our IoT system. This is the end of, we are ending this lecture here. In the next lecture, we will discuss the security challenges and some other challenges that we should consider while designing our IoT system.